Hello, my name is Isabel Hernandez. In this video, I'm going to present a paper on wave physics titled on the possibility of reflectionless propagation of plane acoustic waves in continuously stratified media. This article studies the propagation of acoustic waves, that is, how sound waves move in non-uniform media, such as the atmosphere. The main objective of the study is to analyze under what conditions waves can propagate without reflection, meaning without bouncing or changing their path. I want physics when a wave travels through or changing medium. For example, when the density or the speed of some varies, reflection usually occurs. In other words, the wave can bounce or be deflected due to this variation. Some previous studies suggest that through certain mathematical transformation, it was possible to achieve reflection propagation even in non-uniform media. However, this article challenges that idea and shows that it is not always possible. The article analyzes the propagation of acoustic wave in stratified media, that is, media where properties such as density or sound speed change gradually with height. The authors use wave equations to describe two main variables, pressure and vibration velocity. Through mathematical analysis, it is shown that for a wave that propagates without reflection, both variables must satisfy very specific conditions. The most important result is that reflectionless propagation only occurs when the acoustic impedance of the medium is constant. Acoustic independence is a property that depends on the density of the medium and the speed of sound. This impedance changes reflection will appear. The study concludes that it is not possible to achieve completely reflectionless propagation in media where the acoustic independence varies. It also shows that some previous methods were not entirely correct, since they did not consider all physical variables at the same time. In other words, for a wave not to reflect, a very strict condition is required. The medium must have constant impedance. This is important because it helps us better understand how waves we have in real environments such as the atmosphere or the ocean. In conclusion, this article provides a more precise understanding of acoustic wave propagation and shows that the absence of reflection is limited to very specific conditions. This type of study is fundamental in fields such as acoustic engineering and physics, as it helps improve the analysis of real-world wave phenomena. Thank you.